Welcome students. This lecture video is a part of Procent Public School digital learning program. Okay. So today we continue our chapter 3, electrochemistry, and today we talk about very important equation, that is Nernst equation. It was named after Wilhelm Nernst, a German physical chemist that formulated that equation. Okay. You can see here you have to learn this equation as such because there is a 3 mark question which come into examination, and this is very important reaction. You have to pronounce it as E cell, that means E cell is equal to E naught cell minus 0.0591 divided by N log concentration of product divided by concentration of reactant. I also include the derivation of this Nernst equation in our next slide. You can see here there is the derivation. If you see from the concept of class 11 chapter 6 thermodynamic, we got this equation del G is equal to del G naught plus RT ln Kc. What about this del G? Del G is a change in Gibbs free enthalpy, and del G is a standard change in Gibbs free enthalpy. And as we know that G is equal to minus NF E cell. So by extend this value of del G, we obtain minus NF E naught cell minus NF E naught cell plus RT ln Kc. R is your universal gas constant, T is your temperature, that must be 298 Kelvin. Okay, so by dividing this factor minus NF to the other side, we obtain E naught cell minus this positive and negative side become negative. It will give 2.303. So there is a question that from which this 2.303 will comes. So we see here there is a transformation of this ln into log, that is log. So you can see here we have to convert this ln into log by multiplying with the factor that is 2.303. That is a basic conversion. So ln represent the log in terms of e, while this log represent the logarithm in terms of base value 10. Okay, so e naught e cell is equal to e naught cell minus 2.303 rt log kc divided by nf, and by further solving 2.303 value of R and temperature 298 Kelvin and Faraday, that is 96500 Coulomb. If we solve these all factors, okay, then we got a final answer that is 0.0591. This is a solution of these abbreviations. Okay, so we can replace this abbreviation with the help of this final data 0.0591. It is a constant form of this equation. E cell is equal to E naught cell minus 0.0591. The data is obtained by solving this 2.303 RT upon F. N is as such, log as such, Kc is accent. Kc is equilibrium constant, which means the ratio of product concentration upon reactant concentration. Come to the next. I already told you that this equation is so important because we obtain different relations. Okay. So what are the other formulas? You can see here by putting delta G is equal to 0, and that can be done only when if the reaction is at equilibria. From class 11 chapter number 7 equilibria, we already learned about it, that there is a characteristic of equilibria that at equilibria change in Gibbs free enthalpy must be equal to 0. So by replacing this del G is equal to 0, we got final equation del G naught is equal to minus RT ln Kc. Okay, you can see here if we make this del G 0,
then this RT ln Kc goes to other side and become this positive become negative. So del G naught is equal to minus RT ln Kc that I already written here. Okay, by replacing this del G naught with its value action form minus NF E naught cell is equal to minus RT ln Kc. By dividing this minus NF factor to the other side, okay, this negative and negative cell cancel out with each other, and by dividing this NF factor with the other side, we got this expression 2.303 RT upon F that becomes equal to 0.0591 upon N log concentration of product upon concentration of reactant. So this formula represents the relation between equilibrium constant and standard cell potential. Come to the next, we talk about the different abbreviation that I use in above reactions. The first one is del G, that is change in Gibbs free energy and enthalpy or energy. Del G naught, that is standard Gibbs free enthalpy or energy. Inert cell, that is also known as standard cell potential. What does mean by this standard sign? This naught value represent that this electrode cell potential is measured at temperature 298 Kelvin and the pressure must be 1 atm. Okay. What about this E cell? E cell is called cell potential or EMF, electromotive force. N is the number of electron action during the reaction. Kc is the equilibrium constant in terms of concentration. F is a Faraday that is having value 96500 Coulomb approx. R is a UGC, that is universal gas constant, having value at 0.314 joule per Kelvin per mole. P is a concentration of product and R is a reactant concentration. So we are applying this Nernst equation to the Daniell cell. You can see here the basic expression for the Nernst equation is that you already learn it, memorize it. And if you talk about the reaction that involved in a Daniell cell, so the redox reaction is expressed as Zn solid plus copper 2 plus aqueous gives Cu solid plus Zn2 plus aqueous. By seeing this equation, we find that the zinc solid undergo oxidation and convert into Zn2 plus ion, and this Cu2 plus undergo reduction by getting 2 electrons and convert into Cu solid form. So basically, this I write this reaction because of two data that we obtain from this equation. First is value of N, and another is product and reactant concentration. First we find the value of N. That how we find this value of N? You can see here the arrow that zinc is converted into Zn2 plus by losing 2 electrons. So the value of electron exchange that is become equal to 2. Okay. So in Nernst equation, I replace this N by 2 log product concentration. Now the confusion is that there are two products, one is Zn2 plus and another is Cu solid. But from the concept of equilibria, we already know that we include only this aqueous sign containing product only, not this solid sign containing product. Why? Because the at equilibria expression we consider solid and liquid reactant and product as a unity. Okay, that's why we do not include this Cu solid in a in an expression of Nernst equation. We include this only Zn2 plus ion concentration and copper 2 plus ion concentration. Okay, in examination, this concentration will already given in the bracket. So this is all are about the Nernst equation in terms of Daniell cell. E cell is equal to inert cell minus 0.0591 divided by 2 log Zn2 plus ion concentration and Cu2 plus ion concentration. I prepared some worksheet questions here. So you have to note this worksheet question answers in your notebook as such, because the unit test must contain the questions based on these worksheets. Okay. Students, the first question is write Nernst equation for a Daniell cell that I have already taught you. This is quite important, and I already see this question in examination also for 1 mark. Come to the next question number second. That the relation between standard change in Gibbs free enthalpy and standard cell potential. This question is put up from the uh, different formulas of the Nernst equation. So del G naught is equal to minus NFE naught C. It is good expression. Come to the next question number third. The value of del G at equilibrium is always, that question is put up from the derivation of Nernst equation. Okay, so the del G for the del G at the equilibrium, as you know from the class 11 chapter 7 equilibria, characteristic of the equilibria, the del G at equilibrium must be 0. So the answer is 0. Now the question number 4, write relation in between del G naught and Kc, that is equilibrium constant, in terms of concentration. So the relation is as follow. So this is all are about today lecture. Tomorrow I will continue this chapter. Tomorrow lecture, next lecture, I will continue this chapter with numerical problems related with the Nernst equation. Okay. So before saying thank you, I want to tell you one more thing is that if you don't know about that how we find this law, then I already share a video in our YouTube channel heading how to find log. Okay, so you must know that how we find this law. If you don't know, you see the video from that section. Okay, so this is all are about today lecture. Thanks you for seeing this lecture video. Have a nice day.